Good morning, students. Welcome back to video lecture series for the subject Mathematics 3. Myself, Dr. Ankit Acharya. And in this chapter, numerical solution of linear differential equation, we already discussed about Gauss elimination method using partial pivoting. And in last lecture, we discussed about Gauss-Jacobi method. Okay. So in today's session, we discuss about most important method of this chapter, that is Gauss-Seidel method. Okay, the last method of this chapter. So here you can see that again in this method is applicable to the system of equation in which leading diagonal elements of the coefficient matrix are dominant. The same condition must be happen which we discuss in Gauss-Jacobi method. Okay, so large in magnitude in their respective rows. That means suppose we have three equations and three variables, that means a11x plus a12y plus a13z, that is equal to b1. So must be that this value of a11, see the first condition, the modulus value of a11 strictly greater than modulus value of a12 plus a13. Okay. Similarly, for second equation, this element a22, the modulus value of a22 strictly greater than modulus value of a21 plus modulus value of a23, and this modulus value of a33 in third equation, okay, strictly greater than modulus value of a31 plus modulus value of a32. Okay, so if these three conditions are satisfied, only we can apply Gauss-Seidel method and as well as Gauss-Jacobi method. Sometimes happen that the first condition satisfied the first equation satisfied the third condition, and the third equation satisfied the first equation. So you can interchange the equation first. You have to interchange this first and third equation, and then you can apply Gauss-Jacobi or Gauss-Seidel method. Okay. So let's try to understand once again from the first equation. Okay, the same from the first equation you have to subject as a x, so the value of x from first equation, value of y from second equation, and value of z from third equation. So you will get this three equation easily. Okay, now iteration 1, assuming x is equal to x0, y equal to y0, z equal to z0 as initial approximation and substituting in the equation of x. Okay, so x1 is equal to b1 minus a12 y0 minus a13 z0 divided by a11. Okay, okay, right. So this is iteration number 1. Assuming x is equal to x0, y equal to y0, z equal to z0 as initial approximation and substituting in the equation of x only. So the first iteration x1. Okay, instead of y we have to take y0, and instead of z we have to take z0. Now whatever the value, the first approximation x1, now immediately you have to use in value of y1. That means the first approximation of y. Okay, here you can see that the first approximation of y1 we use x1. Okay, so this is the difference between Gauss-Jacobi and Gauss-Seidel method. In Gauss-Jacobi method, our first approximation is x0, y0, z0. So most probably we are taking x0, y0, z0, 0. So the first approximation x1, y1, z1, right hand side in every place instead of x, y and z we are taking, instead of x, y and z we are taking 0. Okay, but here whatever the first approximation x1 you will get, okay, immediately you have to use that value x1 in y1. Okay, now you have x1 and y1 both, so use the value of x1 and y1 both in z1. Okay, in first approximation of z. So here you can see that now you will get y1. So x1 and y1 immediately you have to use in z1. Okay, okay, this is y1. Clear? Okay, now iteration 2. Now you have x1, y1, z1. So in iteration 2, when you find x2, the second approximation of x, right hand side you have to take y1 and z1. Okay, now when you take the value of y2, iteration 2, okay, when you take y2, right hand side instead of x, now you have x2 and z1. Okay, so in example you can easily understand. So let's try to solve some important example. Okay, solve the following system of equation: 3x minus 0.1y minus 0.2z, that is equal to 7.85. Okay, so since diagonal element c, the modulus value of 3 strictly greater than 0.1 plus 0.2 definitely. Okay, 3 greater than 0.3. Similarly, modulus value of 7 strictly greater than modulus value of 0.1 plus 0.3. Okay, and the modulus value of 10 strictly greater than modulus value of 0.3 plus 0.2. Okay, so the condition is satisfied. Since the diagonal elements are largest, the Gauss-Seidel method can be applied, rewriting the equation. So the value of x, that is 7.85 plus 0.1y plus 0.2z divided by 3. The value of y, okay, easily you can easily understand. The value of x from first equation, the value of y from second equation, and the value of z from third equation. Okay, so 7.85 plus 0.1y plus 0.2z, and here also the value of y and value of z you can easily calculate. Okay, now uh, assuming x0, y0, z0, 0. Okay, so the x1, the value of x1. Okay, just we have to take y0, not x0. Okay, but y0 and z0 you have to take 0, right? Y0, so in first iteration y0, 0 and z0, 0. So what is your first iteration? X1, that is definitely 7.85 divided by 3. So you will get 2.6167. Okay, now immediately you have to use the value of x1 in y1. Okay, so when you find value of y1, instead of x you have to take x1, and instead of z you have to take 0. Okay, so x1, what is your x1? X1 is already you find 2.6167 and 0.3 into 0. So now you will get y1. Y1 is minus 2.7945. All this value you can easily calculate from your calculator. Now you have x1 and y1 both. Okay, this is your x1 and this is your y1. Now x1 and y1 both you have to use in value of z1. Okay, when you find the value of z1, that means the first approximation of z, you have to use value of x1 and y1. Okay, see what is z, the equation z. Now instead of x you have to take x1, and instead of y you have to take y1. Okay, and both the value you already find, that 2.6167 and here minus 2.7945. Sorry. So putting x is equal to x1, y equal to y1. So the value of z1, that is 71.4. Okay, in this equation 71.4 minus 0.3. Okay, x1. Okay, plus 0.2 y1. So 71.4 minus 0.3 instead of x1, 2.6167 plus 0.2 minus 2.7945. Okay, so easily you will get this value 7.0056. Please all the student calculate all this value in your calculator. Now iteration 2, putting y equal to y1, z equal to z1 in equation number x. Okay, now you have x1, y1, z1, first approximation of x, first approximation of y, and first approximation of z. Okay, so now second approximation, when you find second approximation of x, that is x2, you have to take y1 and z1. Okay, the first approximation of y and the first approximation of z. So 7.85 plus 0.1 minus 2.7945 plus 0.2 into 7.0056. So the answer is 2.9906. Okay, putting x is equal to x2, z equal to z1. Now you have second approximation of x2. So when you find y2, you have to use x2. Okay, you can use x2. So minus 19.3 minus 0.1 x2 plus 0.3 z1. Okay, instead of x2 just put 2.9906 and z1, that is already here 7.0056. Okay, so you will get minus 2.4996. Clear? So all this value, now you have x2 and y2 both. okay, x2 and y2 both. So you can use for second approximation in for second to find second approximation of z2. Okay, so just a minute. Okay, so the value of z2, that is 71.4 minus 0.3 x2 plus 0.2 y2. Okay, 71.4 minus 0.3 2.9906 plus 0.2 minus 2.4996. So the final answer is you will get 7.0003. Okay, similarly you have to continue this process until the successive approximation is almost nearby. Okay, now to find the value of x3 you have to take y2 and z2. Okay, y2 and z2 we already find that this is the value of y2, this is the value of z2. So you will get 3, almost x3 is 3.00. Now when you find y3, you can use the value of x3 and z2. Okay, so this is the value of x3 and z2. So you will get almost 2.4999. Okay, and the final approximation for z3, that z3 is almost you will get 7.0000. Okay, so in compared to Gauss-Jacobi method, in Gauss-Seidel method the iterations are almost 3 to 4. Okay, in 3 to 4 iterations you will get almost your exact value, or you can say nearby value. In Gauss-Jacobi method you have to almost 4 to 5 iterations. So Gauss-Seidel method, we can say that Gauss-Seidel method is updated version of Gauss-Jacobi method. Okay, Gauss-Seidel method is modified method. Okay, modified method of Gauss-Jacobi method in we can say. Okay, let's try to solve one more example for Gauss-Seidel method. Solve the following system of equation: 5x plus y minus z, that is equal to 10. Okay, so the x is 10 minus y plus z divided by 5. Y is equal to 14 minus 2x minus z divided by 4, and z is equal to 20 minus x minus y divided by 8. Okay, first assuming x0, y0, z0, so not x0, but first we have to take x0, y0 and z0, 0. So the first approximation x1, that you will get 10 by 5. Okay, so that is 2, 10 by 5, right, so that is 2. Now this 2, the value of 2 you can use for first approximation of y1. Okay, so y1 is 14 minus 2x1 minus z0 divided by 4. So 14 minus 2 into 2 minus 0, so you will get 2.5. Okay, same process. Okay, first you have to see that the diagonal are dominant, right? So 5 greater than 1 plus 1, that you have to check every time, don't forget. 4 greater than modulus value of 2 plus 1, and modulus value of 8 greater than 1 plus 1. So that's why we can continue this process. Okay, okay. Now to find the value of z1, you can use the value of x1 and y1 both. Okay, so x1, y1, x1 is 2, y1 is 2.5, so you will get 1.9375. Iteration 2, y1. Okay, now to find x2 we have to use y1 and z1. Okay, so 10 minus 2.5 plus 1.9375 divided by 5, so you will get x2. Putting x is equal to x2, z equal to z1 in equation of y. Okay, so y2 is equal to 14 minus 2x2 minus z1 divided by 4. So 14 minus 2 into 1.8875 minus 1.9375 divided by 4. So that is 2.0719. Okay, putting x is equal to x2, y equal to y2 in equation of z. Okay, z2 equal to 20 minus x2 minus y2 divided by 8. 20 minus 1.8875, 2.0719 divided by 8, 2.0050. So putting y equal to y2, z equal to z2 in equation of x. x3 is equal to 10 minus y2 plus z2 divided by 5. So 10 minus 2.0719 plus 2.0050 divided by 5. So you will get 1.9866. Okay, and similarly you can find y3, that is to find y3. Now you can use x3, okay, and z2. So right hand side, see x3 and z2. So 14 minus 2, 1 point instead of x3, 1.9866 minus 2.005. So that is 2.0055. Okay, and putting similarly you can continue this process, okay, until the successive approximation near. So up to see this fourth approximation, x4, y4 and z4. x4 is almost 1.9991, and what is the value of x3? That is 1.9866. Okay, so almost equal. You can say x, the value of x you will get 2. Okay, the value of y you will get that is also 2. Okay, 2.002, and here you can see that 2.0055, right? And the value of z, that is also 2. Okay, the value of x, y and z, three of them are 2. Okay, so that you can easily check. So this numerical solution of system of linear equation, this chapter is complete. In this chapter we discuss about Gauss elimination method and Gauss elimination method using partial pivoting, Gauss-Jacobi method in last lecture, and in today's lecture we discuss about important method, Gauss-Seidel method. So thank you.